Welcome to today's video on section 1.3, talking about the different types of functions and their graphs. Couple notes on functions. There are functions that increase, meaning the graphs rise from left to right. So a graph that rises from left to right goes like that. And then, of course, there's a decreasing function which falls from left to right. And then, of course, there's the function that stays the same, that is constant. So then, looking at this, we want to look and see, like, what intervals is the function increasing, decreasing, or constant? Well, if you notice, you want to look at the graph from left to right, and you want to look at the x values from left to right. So notice, if you look from left to right, here it's increasing until you get to this point right here, and then it goes down. So from negative infinity to where x is -1, it increases. Then it decreases from -1 to +1. And then from +1 to infinity, it increases again. Now, the concept of a relative maximum and minimum value. The relative maximum value is basically the top of the parabola. That's the highest point. So if you have a parabola that faces downward, the top is the relative max. And then, of course, a relative minimum value would be the bottom of a parabola. If you have a parabola that faces up, the vertex at the bottom, that is a relative minimum. So it says the graph of the function, use the graph to find where f has a relative maximum and the numbers at which f has a relative minimum. Well, the maximum values, basically, if you notice, the maximum value is here. That's the top of a parabola. And the maximum value is 0, 6. So it occurs at x equals 0, but the maximum value is 6. And the minimum values, they occur right here if you count at -6 and -2, and at 7, -2. If you count over 1, 2, 3, 4, 5, 6, that's 7 and -2. So those are the maximum and minimum points. Now the actual maximum value is 6. The maximum is the y value. It's said to occur at the x, which is 0. So the minimum values occur at -6 and 7, but the actual minimum value is -2, because that's the y. So something to keep in mind is it occurs at x, but the actual minimum and maximum values are the y values. Something to keep in mind. An even and odd function, and how that relates to symmetry. Well, first of all, to figure out an even function, if you have f of x and you put a -x in, you get what you started with. And an even function is symmetric to the y-axis. And an odd function, when you put negative x in, you get the opposite of what you started with, and that would be symmetric to the origin. So to determine whether each of the following is even, odd, or neither, well, you put a negative x in. So when I put a negative x in, when I square negative x, I get x squared. And notice it's the same thing that I started with, therefore this is an even function. Now if you notice here, if I put a negative x in, negative x to the third gives you negative 7x to the third, and then negative and negative is positive. So now if you notice, if I pulled out a negative, notice when I pull out a negative, I'm left with 7x to the third minus x. So notice I have the opposite of what I started with. Therefore, that is an odd function. And then here, if I put a negative x in, whoops, don't need parentheses there. Negative x to the fifth gives me negative x to the fifth minus 1. So if I take out a negative here, if it doesn't give you the same thing, take out a negative to see if it's odd. So if I take out a negative here, notice I get x to the fifth plus 1, and that is not, oh sorry, I don't know why I wrote minus, so plus, and this should be minus, sorry. So it gives me negative x to the fifth plus, or minus 1, and since it doesn't give me the opposite, then this would be neither, because it's not the same, and it's not the opposite, so therefore it's neither even or odd. So as I said earlier, even functions are symmetric to the y-axis, like y equals x squared. So something that would be symmetric to the y-axis would be something like this, like a parabola. Notice how it's the same on both sides of the y-axis. Yes. So that is an even function because it's symmetric to the y-axis. An odd function is symmetric to the origin, which means the origin would be the same on both sides. So something like this right here, where you have the origin acts as a mirror, where notice you have the opposite point. So notice how y is 1 here, and it's negative 1 there. Like notice the points 1, 1, and then here it's negative 1, negative 1, so you have the exact opposite. That means it's symmetric to the origin. So that would be an odd function. The last type of function we're going to talk about here is a piecewise function. And this is one that's basically in two parts. So here's the deal. First of all, you decide, it gives you restrictions. So between 0 and 60, you would put it in this top part. And when it's greater than 60, you put it in the bottom part. So 40 is between 0 and 60. So, and then it says if it's between 40 and 60, the answer is 20. So f of 40 would be 20. 80 is greater than 60. So if it's greater than 60, you put it in the equation 20 plus 0.4 times 80 minus 60. 4 times 20. 0.4 is going to give you 8. And 20 plus 8 gives you 28. Graphing a piecewise function, you split it up into two parts. So basically you do the first part. The first part basically says f of x equals 3. That's the same as graphing y equals 3. That is a horizontal line. And notice it's only when x is less than or equal to -1. So when we go to -1 here, we know that y is equal to 3. And when it's less than -1, we know that that's the line. So we graph y equals -3 there. The second equation, f of x equals x minus 2, well, that's all the values that are greater than -1. So if I start with -1 and make a table of values greater than -1, -1 minus 2 gives me -3, 0 minus 2 gives me -2, -1, 0, and 1. So notice -1 is -3, which is down here. Now, to represent that it's not equal to -1, I'm going to put a circle there. Then 0, -2, I put a dot. 1, -1, 2, 0, 3, 1, and I graph it. So notice I have two parts because it's a piecewise function, meaning it's got two separate parts. The first part is when it's less than or equal to -1. That's when it's y equals 3, and that is my horizontal line. And then the second part, when it's greater than -1, I drew my line making the table of all the values greater than -1. I leave the open circle at -1 because it's not equal to -1, it's just greater than. The last actual concept is a difference quotient. And basically here what we're going to do is, first of all, let's find f of x plus h. So that means to take the x plus h and substitute it in for x. So everywhere I see an x, I'm going to put an x plus h. So I FOIL. Plus 3. So now when we FOIL, we get x squared plus 2xh, because you have x times h and x times h, and then plus h squared. Distribute the negative sign, so you get minus x minus h plus 3. So then distribute the 2. And notice if we combine like terms here, which there are none of, so basically this is our final answer, which looks a lot long, but it's an answer. It's just not pretty, but it's an answer. So the main thing here is this difference quotient. It's a difference quotient because you subtract and you're dividing, so therefore it's a different quotient. So it says f of x plus h minus f of x. Well, we just found out what f of x plus h is. It's this big long mess here. So we're going to substitute in 2x squared plus 4xh plus 2h squared minus x minus h plus 3. That is f of x plus h right here. F of x, it told us what it is right here. It's 2x squared minus x plus 3. So we're going to subtract that. Let's move that over. Plus 3. And then divided by h. So notice we're going to distribute here. We'll distribute the negative sign. So we get 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Distribute the negative sign now, so it's negative 2x squared plus x minus 3. And then it's all over h. So notice there's some like terms that cancel out. There's the 3's. There's the x's. And then there's the 2x squareds. So you're left with that. So now, if you notice, they all share an h in common. So if you factor out that h, you can cancel it out. And you're left with 4x plus 2h minus 1. And that's our final answer. All right, I apologize. A couple times I had to pause it and start over just because some people walked in. So if you see some gaps in the video or some pauses, that's just what happened. Hopefully you were able to watch it and take notes. We'll work more with the difference quotients because that can be a little difficult and challenging. So I'll see you guys tomorrow, and enjoy the rest of your evening.